Section 3. Transferring power to wheels. Mechanical transfer. Now for the brilliant handoff. On one side, we have the electrical flow. So the diesel or electric source, the generator, and the inverter that we just talked about. On the other side, we have the mechanical power, the traction motors, the axles, and the wheels. This is the magical transition point in our animated journey. It is exactly where raw, buzzing electricity is successfully converted into physical, ground-shaking mechanical power. I mean, it's the whole reason the train can actually pull those incredibly heavy passenger coaches down the line in the first place. So here are the final critical steps in that mechanical power transfer. First, that newly conditioned electrical energy transfers directly to the traction motors. Second, those traction motors get to work, generating literally thousands of pound-feet of torque to physically rotate the axles. And third, those turning axles directly drive the rotation of the wheels. And just like that, our glowing arrows of energy have traveled all the way from the internal engine down to the complex machinery and have finally hit the tracks to create real physical momentum. Section 4. Motion and braking systems. Controlling momentum. All right, so we've successfully generated power, we've transferred it to the wheels, and we are absolutely flying down the tracks. But, that brings up a massive, heavy question. Once all this energy becomes high-speed motion, how is it actually controlled? I mean, when you have a massive locomotive pulling thousands of tons, generating speed is actually kind of the easy part. The real engineering marvel is how you safely rein it all in. This is where the animation blueprint utilizes our transparent cutaway view once again, revealing the internal braking system in action. But it's not just some static, boring drawing. No, the source material emphasizes using deep, sensory details to make this feel vivid and urgent. It pairs the visual of the brakes controlling the momentum with realistic sound effects and smooth, cinematic camera movements. What's super incredible here is that many modern trains use dynamic braking. Basically, they literally turn those massive traction motors into generators to bleed off speed, which creates an immense amount of heat and electrical resistance. By engaging our eyes with dynamic lighting and our ears with the intense sounds of these forces engaging, the mechanics of slowing down this absolute behemoth become a truly immersive, memorable learning experience. And that brings us to the visual payoff of the entire piece. After deconstructing all those hidden components, the inverters, the axles, the traction motors, the brakes, the animation pulls back. We exit the transparent cutaway view for a stunning cinematic finale, showing the fully functional train moving at high speed through a vast, beautiful landscape. It is the perfect, quiet, concluding shot. We can now truly appreciate the profound beauty of the machine moving seamlessly through the world, because we finally understand the complex, step-by-step symphony of engineering happening underneath the hood. Which leaves us with this final provocative thought to ponder. How does visualizing these hidden mechanical flows change the way we understand the massive machines we rely on every single day? When we use brilliant educational tools like glowing arrows and transparent cutaway views to bridge raw engineering with accessible storytelling, the everyday world around us suddenly becomes infinitely more fascinating. Next time you see a modern train zooming by, you won't just see a metal box on wheels, you'll see the exact